Hello and welcome. We're going to talk about the quadratic formula. So a quadratic equation, as we've seen already, the general form of it is ax squared plus bx plus c equals 0, where a, b, and c are real numbers. Now, I'm not going to bury the lead. The solution or solutions potentially are in this form. You can just plug in the coefficients a, b, and c into this formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Some context here. Let's look at what we've looked at before at the quadratic function. Which is just y equals ax squared plus bx plus c. In this case, we have two places where this function crosses the x-axis. We call those zeros. X-intercepts. It's basically the points on the x-axis where the graph crosses it. Essentially, y equals 0. So to find the zeros of, or the x-intercepts of a quadratic function, you basically set y equal to 0 and solve. So in this particular case, we have two places where the graph crosses the x-axis. So we would have two real number solutions. It could look like this, where the graph just basically kisses the x-axis, and that's one real solution. Technically, it's what we call a repeated solution. Or, this graph could just not cross the x-axis at all. It could be floating up here. There are 0, I'll say, real solutions. Basically, you'll have two complex solutions. In this case, complex numbers getting into imaginary numbers and such, which I'm not going to get into right now. Whether you have 1, 2, or 0 solutions is kind of dependent upon this part here under the square root, that b squared minus 4ac. If that's positive, then you're good to go. You'll have a plus or minus, a positive number, and that'll give you your two zeros for that quadratic function. You'll have one real solution if b squared minus 4ac is exactly 0. You can kind of imagine if this whole thing is 0, then it goes away, and you just have negative b over 2a. There's no plus or minus because it's just 0. And if b squared minus 4ac is less than 0, then you have a situation where you have a negative number underneath the square root, which isn't defined for real numbers. Those are your three major cases with this quadratic formula. So let's take a look at some examples. I'll give you a quadratic equation, and I'll do it with factoring and with a quadratic formula, just so you can kind of see how both work. Sometimes factoring is quicker. Sometimes the quadratic formula is quicker. Some quadratic expressions don't factor nicely. In those cases, you'd have to use the quadratic formula. 2x squared plus 11x minus 6 equals 0. There's our quadratic equation. Everything's on the left side, equaling 0 on the right, so we're good to go. We can identify our a, b, and c here. But first, let's look at factoring it. And I'm going to factor this using the AC method. AC is 2 times negative 6. It's negative 12. I just need to find two numbers that multiply to negative 12, whose difference is 11. So I'll write this 12 here. And I'm looking at a difference because it's negative. They're different signs, right? We could go through all of these, but I think we're going to find it pretty quick. Oh, there it is, 1 and 12. 1 and 12, the difference is 11. That's all we need. Which one's positive, which one's negative? Well, our b term is positive, so our 12 has to be positive, and our 1 has to be negative. We now need to split up that 11x into 2x squared minus 1x plus 12x minus 6. And then we factor by grouping. We can factor out an x out of these first two terms. We get 2x minus 1. And we can factor out 6 out of these. We get 2x minus 1. We're looking for that 2x minus 1 there. And now we can factor out the 2x minus 1. We get x plus 6 times 2x minus 1 equals 0. And that, now we have two mini equations. X plus 6 equals 0, or x equals negative 6. And 2x minus 1 equals 0, or x equals 1/2. So there's our solutions. X equals negative 6, or 1/2. So sometimes factoring is a better solution. But sometimes if you don't see how to factor it, if it's not obvious, well, you just go to the quadratic formula. So let's do that. So I usually write down the quadratic formula first. X is negative b plus or minus b squared minus 4ac all over 2a. I write it down just so I remember it. You know, the more I write this down, the more I'll remember this. I'm just going to plug in the numbers. Negative b, negative 11, plus or minus the square root of b squared. Now it's negative 11 squared. I'll write it here. In the future, I'll probably just write 11 squared because I know that negative is going to get killed off anyway. But anyway, so negative 4 times a, which is 2, times c, which is negative 6. All over 2 times a, which is 2. Negative 11. Now we're just in a situation where we have to use order of operations and simplify this expression. You could probably plug this into your calculator, but oftentimes I'll simplify it as best I can before I type it into a calculator. Negative 11 squared is 121, positive 121. Here we got a negative 4 times negative 6, which is positive 24, times 2, which is, so we got positive 48, all over 4. Negative 11 plus or minus the square root, 169 over 4. This is negative 11 plus or minus square root of 169. 169 is a perfect square. It's 13 squared, so this is 13 over 4. So now we got a negative 11 plus 13, which is 2 over 4, and negative 11 minus 13, which is negative 24 over 4. Simplify those, you get 1/2 and negative 6. And that's it. So let's look at another one. Let's see if we can squeeze it in here. Let's solve this. 4x squared minus 10x minus 1 equals 0. So again, our quadratic formula, b squared minus 4ac all over 2a. Identify your a, b, and c. A is 4, b is negative 10, c is negative 1. That's important for when we plug these numbers in. So negative b is positive 10, plus or minus 10 squared. I'm just going to write 100. Right, it's technically negative 10 squared, but the negative gets killed off. That's minus 4 times a, which is 4, times c, which is also negative 1, all over 2 times 4, or 8. That's 10 plus or minus square root of 100. Now this is negative 4 times negative 1. That's plus 16 total over 8. So this is 10 plus or minus square root of 116 over 8. So if you're going to leave this like this, you could leave this answer like this for those two solutions. You could simplify this to 5 plus or minus the square root of 29 over 8 if you have, or sorry, over 4. If you have any questions about that, I can explain how that works. But probably more often than not, at this point, you would get a couple decimal solutions. For 5 plus square root of 29 over 4, if you type that out, you get 2.596 if you round it to the nearest thousandth. And 5 minus the square root of 29 over 4. Now remember, when you type this in your calculator, you probably will need to put parentheses around 5 plus square root of 29 or 5 minus square root of 29. 5 minus square root of 29 is negative 0.096 or thereabouts. So those would be your two solutions. So it won't always come out nicely. You'll have nasty square roots. In fact, more often than not, you'll have nasty square roots. If you don't have nasty square roots, chances are you could factor it. Let's do a couple more examples. Here's one, 3x squared plus 6x plus 7 equals 0. So x equals negative b plus or minus. Again, I'm just going to keep writing it every time until I remember it. I highly recommend you do this too. So, and I'm going to now plug in those numbers. A is 3, B is 6, C is 7. So they're all positive, so we'll see what that does with the problem. 6, negative 6, plus or minus b squared, which is 36, minus 4 times 3. I'm just going to write it out because I can't do this part in my head. 4 times 3 times 7, 4 times 3 times 7, all over 2 times 3, which is 6. So you get negative 6 plus or minus. If you do that calculation on the inside, you're going to get negative 48. Because this negative 4 times 3 times 7, that's going to be larger than 36. You probably already will suspect that immediately. And here's the deal. We've got a negative number underneath the square root. That's not a real number. If we're getting into complex numbers and imaginary numbers, we could continue and there would be a complex number solution. But as it is, once you see that negative number under the square root, you can see there's no real solutions. If all you're looking for are real solutions, then you can say, well, there are none. Done. So what if your equation isn't in that standard quadratic form? Well, you just would solve to get it into that form. For example, let's solve x squared equals 3x plus 5. So I want to get all these terms on one side and 0 on the other. I want to keep the coefficient on the x squared term positive, if at all possible. It's just a good habit to be in. So I will subtract 3x from both sides and subtract 5 from both sides as well. So on the right side I'll have 0, on the left side I'll have x squared minus 3x minus 5 equals 0. So A is 1, B is negative 3, C is negative 5. So our solutions are negative b, which is 3, plus or minus square root of b squared, which is negative 3 squared, which is 9, minus 4 times 1, which I won't write, times c, which is negative 5, all over 2 times 1, which is 2. So this is 3 plus or minus 9 plus 20. That minus 4 times negative 5 makes it plus. So this is 29 inside here, all over 2. Now that's pretty much it. You could write it as 3 plus square root of 29 over 2 and 3 minus square root of 29 over 2. Or you could write it as decimals. You could just type these out on your calculator and get decimals, and that's, you'll get 3 plus square root of 29 over 2 is 4.193, about, rounded to the nearest thousandth. And 3 minus the square root of 29 all over 2 is negative 1.193. So depending on what your problem is asking for, those are the solutions. That's all I have for right now. I'll see you next time.